Okay, this lesson is on solving rational equations. Rational equations are fractions with constants and variables in the denominator. We've done some of these in chapter 2 when we were solving equations. We're going to do a few more here, and then we're going to add some with the variable in the denominator. Now, in order to solve these types of equations, I like to solve, we have to get common denominator. Now, sometimes your common denominator will be a number, sometimes it'll have a variable in it. It just depends. Alright, so let's look at some problems where we have to find the common denominator first with numbers. Now, this one's pretty straightforward. I've got 3 different denominators. I've got a 3, a 2, and a 5. I need to find the common denominator for all 3 of those. Well, the common denominator between 3 and 2 is 6, and between 6 and 5 is 30. So the common denominator is going to be 30. Alright. So we're going to take what's in the denominator, divide it into the 30, goes 15 times, multiply the 15 and the x. Here, 2 goes into 30. Oh, hold on, y'all. Back up. I made a mistake. 3 goes into 30 10 times. 10 times x is 10x, not 15. 2 goes into 30 15 times. 15 times 1 is 15. 5 goes into 30 6 times. 6 times 2 is 12x. Alright, we'll move the 10x over. So we'll get 15 equals 2x divided by 2, so x is 15 halves. We've done problems like this, so hopefully this is a little refresher course. Alright, look at this one. I've got a 7 and a 3 in my denominator. The common denominator between 3 and 7 is 21. So now we're going to divide. 7 goes into 21 3 times. Multiply the 3 and the 3x together, get 9x. 3 goes into 21 7 times. Multiply the 7 and the x. This side there's no fraction, so we just multiply 21 times 2 is 42. Combine like terms. Divide by 16. 42 over 16, which simplifies down to 21 over 8. This one we got 3 different denominators again. 4, a 2, and a 6. So I need the LCD between the 2, the 4, and 6, which is going to be 12. Now, do the dividing. 4 goes into 12 3 times. This time, though, I've got a 3 and I've got a binomial. And not just a number, but a binomial. This one, 2 goes into 12 6 times. We got 6 times 2x minus 3. 6 goes into 12 2 times. 2 times 5 is 10. Do the distributive property. Add like terms. And solve for x. So we're going to move the 15 over just like normal. 25. Divide by 15. So x turns out to be 5/3. Now, we're going to be doing some that have x's in the denominators. Now, these are a little bit different. I mean, they don't work any different. They just, when we've got x's in the denominator, we have what we call restrictions on x. Restrictions. Answers are restricted based on an x being in the denominator. Now, one thing you should have learned about fractions a long time ago was that you can never have you can never have 0 in the denominator of a fraction. So, we're restricted to what makes x be 0. Okay? Now, for right now, all of these problems, my restriction is going to be right here. This is the restriction, where x cannot be 0 on these following problems. Once I start doing other types, it may make a little more sense. But for right now, you have to specify, because they're monomials, it can't be 0. Now, going back to the complex fraction section, where we had to find the common denominator and multiply everything by the common denominator. You know, it's the same thing. If I've got x's in my denominator, here's an x in my denominator. That means in the parentheses I gotta have an x. I don't have any choice. Now I've also got a 3 and a 5 in the denominator. I gotta find the common denominator between the 3 and 5, which is 15. So because there was an x, the x has to go in parentheses. Then we find it for the two numbers, the 3 and the 5, which is 15. Now comes our dividing. Do the same thing. The x in the denominator takes out the x in the parentheses. What you're left with is just 15 times 2, which is 30. This one, 3 goes into 15 5 times. We take the 5 and the x, multiply those together, get this. On the right side, look what happens. The x takes out the x in the parentheses. The 5 goes into the 15 3 times, and we're left with 12. So, if there's an x in a denominator, it goes in the parentheses. Now we're going to subtract 30 from both sides. 5x will be negative 18. So x turns out to be negative 18 fifths. That's my answer. Alright, look at this one. Again, there's an x in a denominator. That means there must be an x in all my parentheses. There's also two numbers in the denominator. So I need to find the common denominator between the 2 and the 8, which of course is 8. Now comes our division part. Here, the x's cancel themselves out. 2 goes into 8 4 times. Multiply the 4 and the 3. The second piece, there's no fractions at all, so it's just straight multiplication. Nothing to do there. Now notice here, 8 takes itself out with this 8, and we're left with 5x. Now I'm just going to solve it like normal. Subtract 32x from both sides. We get 12 equals negative 27x. Divide by negative 27. So x turns out to be negative 12 over 27, which is negative 4/9. Alright, let's look at this one. Do the same thing. There's x's in the denominator. Automatically, that means I'm going to have an x in my parentheses. Also, oops, let me do that. There are 3 different numbers in the denominator. 3, the 2, and the 4. I need the common multiple between the 3 and the 2 and the 4, which is 12. So, If there's an x in the denominator, it takes out the x in the parentheses. And we divide the 3 and the 12, it goes 4 times. 4 times 2 is 8. Here, we divide the 2 and the 12, it goes 6 times. We multiply the 6 and the x together. Now here, the x's take themselves away, go away completely away. Multiply the 12 and the 7 to get 84. Now this side, the 4 divides into the 12 3 times, and we're left with minus 3x. Now, I am going to subtract 8 from both sides, and I'm going to add 3x to both sides. So I'm going to end up with 9x on, hold on. I'm going to end up with 9x on the left and 76 on the right. Divide by 9. So x turns out to be 76 ninths. No, let me fix that. So on all of these problems, I had a restriction where x cannot be 0 because this means I can't have x to be 0. This cannot be 0. Because that's invalid. So if there's an x in the denominator anywhere, my restriction is x cannot be 0. This is the restriction. You've got to remember that.